In our previous session, we discussed process of forecasting. Today, we are going to explore a very new topic, and that is methods of forecasting. Imagine you are the head of a rapidly growing company launching a new product line. So, to meet future demand and stay competitive, you must predict sales and market trends very accurately. So, what methods would you consider to forecast these data? So, how would your chosen method shape your strategy and ensure your company stays ahead in a dynamic market? So, at the end of this topic, you will be able to list out main methods of forecasting. You'll also be able to explain application of forecasting methods and strategies. In the context of forecasting for an existing product, we begin by emphasizing the importance of utilizing historical data to make informed predictions about future performance. Historical data serves as a foundation, providing insights into past sales trends, customer preferences, and market fluctuations. By analyzing this data, we can identify patterns that may influence future demand. For instance, we examine seasonal variations, promotional impacts, and macroeconomic factors that have historically affected sales. We then apply various forecasting techniques such as time series analysis, moving averages, or exponential smoothing to generate projections. These methods enable us to quantify expected future sales and identify potential risks and opportunities. Moreover, incorporating external data such as market research and competitor analysis can further enhance the accuracy of our forecast. Ultimately, the objective is to create a reliable forecasting model that informs strategic decision making, optimizes inventory management, and aligns production capabilities with anticipated demand, ensuring that the product continues to meet customer needs effectively. Forecasting product life cycle is essential for understanding how demand fluctuates as a product progresses through its various stages. Initially, demand for a new product typically starts at zero, gradually increasing as the product gains market acceptance and awareness. As the product matures, demand may peak before eventually declining as the product becomes outdated or obsolete. For instance, products like the iPhone and iPad illustrate this phenomenon, experiencing significant growth and eventually facing diminishing demand as newer technologies emerge. In contrast, fixed telephones serve as an example of a product that has largely fallen out of favor, leading to a decline in demand over time. It is crucial to recognize that applying forecasting methods mechanically without considering the current stages of the product in its life cycle can result in significant inaccuracies. Therefore, understanding where a product stands within its life cycle is vital for creating accurate demand forecast, ensuring that the businesses can effectively manage production, marketing, and inventory strategies in response to shifting consumer preferences. In the presence of various forecasting methods, selecting the appropriate technique is crucial for accurate predictions. The choice of forecasting method is primarily based on factors such as the nature of the product, the availability and the quality of the historical data, the time horizon for the forecast, the desired level of the accuracy, and the specific goals of the forecasting process. The following are the factors on which choice of forecasting method is based. Form of forecast required. Data availability, behavior of process being forecasted, case of operation. Forecast horizon, period and interval, accuracy required, cost of development, installation and operation, management comprehension and cooperation. Forecasting methods can be divided into two main categories, qualitative and quantitative. Qualitative methods such as the Delphi technique and market research rely on expert opinions and the subjective judgment, often used when the data is scarce. Quantitative methods, on the other hand, utilize numerical data and statistical models, including time series analysis, causal models, and trend projection. These techniques identify patterns in historical data to predict future trends. Choosing the right method depends on the factors like data availability, forecast horizon, and the accuracy required, ensuring businesses can make informed decisions based on reliable predictions. Qualitative forecasting methods are based on expert judgment, intuition, and opinions rather than relying on the numerical data. These methods are particularly useful when historical data is limited, unreliable, or when forecasting new products or markets. Since qualitative methods rely on subjective assessments, they are often used in scenarios where precise numerical predictions are less critical and strategic insights or expert knowledge are more valuable. Some of the qualitative methods include market surveys, nominal group testing, historical analysis, jury of executive opinion, life cycle analysis, and Delphi method. Let's understand each of the qualitative methods techniques in detail. First, let's explore market survey. Market surveys are a popular qualitative method of forecasting, particularly useful for gauging demand for new products or services. In this approach, surveys are conducted among prospective buyers by circulating questionnaires to gather their responses on preferences, expectations, and purchasing intentions. The collected data is then collated and analyzed to identify potential demand trends and customer sentiment towards the new product. For example, before launching a new smartphone, a company may conduct a market survey to understand what features customers value the most. Based on the survey results, the company can forecast potential sales and adjust its product features or marketing strategies accordingly. However, market surveys come with the limitations such as sample bias, where the respondents may not accurately represent the entire target population, potentially skewing the forecast results. Despite this, market survey remain a valuable tool for obtaining early insights into customer behavior. Next is nominal group testing. Nominal group testing is a qualitative forecasting method where a product or service is provided to a specific group such as students, employees, or neighbors for the trial use. After experiencing the product, participants share their responses, which are then collected and analyzed to assess their opinions, preferences, and potential demand. This method helps businesses gather direct feedback on a product's strengths, weaknesses, and overall appeal before its wider market release. For example, a company may give a newer software application to employees to test its usability and features. Based on the feedback, improvements can be made and demand can be forecasted. While effective in gathering detailed feedback, the representativeness of the selected group is crucial for ensuring the accuracy of the forecast. Third is historical analysis. Historical analysis is a quantitative method of forecasting based on the premise that past events and patterns can serve as indicators of future outcomes. This approach involves analyzing historical data to identify trends, cycles, or patterns that can be associated with future events. By examining past sales, market behavior, or customer preferences, businesses can make predictions about future demand. For instance, a retail company might analyze its previous year's holiday sales data to forecast demand for the upcoming season. Identifying recurring trends like increased demand for specific products in December. Similarly, historical weather data could be used to predict future agricultural yields. While historical analysis can be highly effective, it assumes that the past conditions will remain relatively constant, which may not always hold true, especially in rapidly changing industries or markets. The jury of executive opinion is a qualitative forecasting method where the collective opinion of a group of experts or senior executives is used to estimate future outcomes. In this method, experts from relevant fields such as marketing, finance, and operations share their insights based on experience, market knowledge, and industry trends. These opinions are then synthesized to create a forecast. For example, in a company launching a new product, executives from sales, marketing, and R&D might collaborate to predict sales performance based on their respective expertise and understanding of market dynamics. This approach is particularly useful when data is scarce or when subjective judgment is required, such as predicting demand for an innovative product. While this method leverages valuable expert insights, its limitation lies in the potential biases or differing viewpoints, which can influence the final forecast. Life cycle analysis as a forecasting method involves assessing the current stage of a product within its life cycle and using this information to form an opinion about future demand. Products typically go through several stages. They are introduction, growth, maturity, and decline. By determining where a product lies within this cycle, business can estimate future trends and make strategic decisions. For example, if a smartphone is in its growth stage, a company may forecast increasing demand and ramp up production. Conversely, if a product is in its decline stage, like traditional landline phones, the forecast may predict reduced demand, prompting the company to reduce inventory or phase out the product. This method is valuable because it recognizes that the demand changes as a product moves through its life cycle. However, accurately identifying the life cycle stage is critical for the reliable forecasting. Lastly, the Delphi method is a structured forecasting technique that relies on gathering the opinions of a panel of experts. In this method, a coordinator collects feedback from the experts, often through questionnaires, and shares the anonymized responses with the group. Multiple rounds of discussion are held during which experts can refine their opinions based on the collective input, ultimately aiming to reach a consensus. This process ensures that the forecast is based on the informed judgment of experts rather than on individual biases. For example, in the tech industry, the Delphi method may be used to forecast the future of artificial intelligence by consulting AI researchers, software engineers, and industry leaders. Their combined insights after several rounds of discussion can lead to a well rounded prediction of the technology's trajectory. The Delphi method is particularly useful when precise data is unavailable and expert knowledge is critical, although it can be time consuming due to iterative rounds required to reach a consensus. Quantitative forecasting methods involve collecting adequate data and applying statistical techniques to identify patterns that aid in making future predictions. These methods are data driven, relying on numerical information such as historical sales, economic indicators, or market trends to generate accurate forecast. Because the reliability of these methods depends on the quality of the data, it is crucial that the data is free from errors and bias to ensure sound conclusions. Quantitative methods can include the time series analysis, regression models, and the trend projection, among others. The availability of the user friendly software like MS Excel and specialized tools make data analysis more accessible, allowing businesses to apply these techniques efficiently. This ease of application enables organizations to make well informed decisions by interpreting complex data in a straightforward manner, making quantitative forecasting both practical and powerful for diverse industries. One of the most commonly used quantitative methods is time series analysis. Time series analysis involves a set of values pertaining to a specific variable collected at regular intervals over time. This method allows analysts to observe patterns, trends, and seasonal variations in the data. For instance, recording hourly temperature readings or annual rainfall measurements provides valuable insights into weather patterns and climate trends. However, for time series analysis to yield reliable forecast, it is essential to have an adequate number of observations. A low sample size, such as only 7 or 8 data points, is unlikely to provide a comprehensive view and can lead to inaccurate forecast. A large data set enhances the ability to identify meaningful trends and patterns, enabling more accurate predictions about future values based on historical performance. Therefore, ensuring sufficient data availability is crucial in the application of time series analysis for effective forecasting. The following are the four components of the time series. They are trend, cyclic, seasonality, random. Time series data comprises four key components that help in understanding and forecasting trends. Trend refers to the gradual upward or downward movement of the data over an extended period. For example, a consistent increase in sales figures over several years indicates a positive trend, while a decline in product's popularity shows a negative trend. Cyclic patterns involve repetitions of the data at the regular intervals, often spanning several years. Business cycles are a common example as they help analysts understand the mood of the markets and anticipate economic fluctuations based on historical cycles of the expansion and contraction. Seasonality represents repetitive patterns observed over shorter time frames, such as days, weeks, or months. For instance, retail sales often peak during holiday seasons, reflecting a seasonal pattern that can be tracked and predicted. Random components are unpredictable and caused by chance factors or unusual events. These can include natural disasters or sudden market changes, making them difficult to forecast but essential to consider when analyzing the time series data. Together, these components provide a comprehensive framework for understanding the behavior of time series data and improving forecasting accuracy. In the time series forecasting, the naive method is a simple yet commonly used approach where the forecast for the next period is assumed to be the same as the value of the most recent observation. This method is based on the assumption that the data does not exhibit any trend or seasonal pattern, making it particularly effective for stable time series where fluctuations are minimal. For example, if we are observing monthly sales data and the sales for the last recorded month are 500 units, the naive method would predict that the sales for the next month will also be 500 units. So the key advantage of this method lies in its simplicity, as it requires no complex calculations or assumptions about the underlying data. However, its limitations become apparent when applied to time series data with trends or seasonality, where more advanced models like exponential smoothing or ARIMA, which is termed as ARIMA, would be more appropriate. The naive method is often used as a benchmark to evaluate the performance of more sophisticated forecasting models. In time series forecasting, the moving average method is a widely used technique where the forecast is obtained by averaging the values of the time series over a specified number of periods. This averaging is done repetitively where the oldest value is deleted and a new value is added as time progresses. The number of periods chosen is typically an odd number such as 3, 5, or 7 to ensure symmetry around the middle point. This method smooths out short-term fluctuations in the data, making it useful for identifying the underlying trend. However, one major drawback of the moving average method is that it assigns equal weight to all the observations within the averaging period, which may not accurately reflect more recent changes in the data. Additionally, it does not account for any seasonal patterns in the time series, limiting its effectiveness in cases where seasonality plays a significant role in the data behavior. Despite these limitations, the moving average method remains a simple and effective tool for smoothing time series data and providing short-term forecast. The moving average method in time series forecasting, while simple and effective for smoothing data, has a limitation. It assigns equal weight to all the past periods within the averaging window. This can lead to the forecast being disproportionately influenced by the larger or unusual values, particularly in dynamic or changing environments where older data become less relevant. To address this, the method is often modified into a weighted moving average, which assigns different weights to different time periods, giving more emphasis to recent data. This adjustment helps the forecast better reflect recent trends or changes. However, the selection of the weights can be somewhat arbitrary, often determined through a trial and error process where different weight combinations are tested to find the most suitable model for a particular time series. This modification makes the weighted moving average more adaptable and responsive to evolving patterns in the data. The exponential smoothing method is a refined version of the weighted moving average method designed to assign weights to historical data in an exponentially decreasing manner. This means that the most recent observations are given the most weight, while older data points receive progressively less weight. The method gets its name from this exponential weighting system, where the influence of each past value diminishes as the data gets older. Exponential smoothing is particularly effective in capturing recent trends in the data, making it more responsive to changes in the time series compared to the simple or weighted moving average methods. Since the weights decrease exponentially, the method naturally adapts to changes in the data without requiring arbitrary choices for weights, as is often the case in other methods. This makes exponential smoothing a widely used technique in forecasting, especially for data with no clear seasonal or cyclical patterns. In this session, we have learnt about forecasting is broadly classified as quantitative and qualitative. Qualitative methods include market survey, like Delphi method, historical analysis, etc. Quantitative methods are basically divided into two groups. They are time series analysis and causal method. That's it for today. Thank you. Happy learning.